Time for another draftphysics.com video presentation. I don't think we'll need anything else. I'll just, do this thing. Chalkboard. Chalk. I try to explain context here. So there's theory about stuff. People come up with theories, and so you go. Benjamin Franklin kind of thought electricity was like a fluid, so that's his model. That's what he used to kind of explain how things move from one place to another. Faraday had a whole bunch of ideas about gears, and that's how magnetism worked, because there's a bunch of gears inside of everything. I would argue that, modern science gives us some advantages in that we know there's atoms and that we know at least there's players like electrons and protons. But I would argue that people still haven't come up with physicists, scientists. They kind of gave up on models of movement because they came up with stuff like bent space, and you can't really model that in 3 dimensions in any kind of coherent way. And quantum mechanics became kind of just wacky field kind of mechanics. Now, I could argue that, quantum field theories have some sort of, mechanicalness to them, and it should give them some insight into the fact that, you're really just trying to follow, the energy. And so this whole subject of energy comes up, and who knows what exactly Newton was thinking, and Descartes, and then Leibniz, and all these people, about what the actual stuff was that was inside of something. Now, I could argue that Leibniz, the guy who eventually won, and I think a horrible victory, believed in solitons. And soliton means soul, like God stuff. And, monads are what he called things. Weird, really bizarre little aliens were living, little free will aliens and stuff. So it's a really bad theory, of what constitutes why something has motion. So, I'll just start and see where it goes in terms of, I'm just trying to explain why it seems obvious to me, and I'm sorry there's, people are so offended, because, I think there has to be a physical model. The universe is working because there's physical things happening in the physics. The physics shouldn't involve, magic. All right, so it really starts with just these electrons and protons and why do they move. And I've tried to explain that, there's a couple of theories. You could say something bangs into them and bounces off, in some sort of way, and then they keep going. Or, as have kind of figured out, that no, the real key to it is yes, the force stuff does hit it, okay, but it doesn't just bounce off. What it does first is push it, and so it goes with it. The two objects go together in this direction until some counter force hits from the other direction, some other direction, and it causes it to reflect this bit, and then this bit reflects. And so you can have an instantaneous reflection if the thing is moving already and you bang into it. But if you're going in the direction it's going, or it's not going in a direction, there's no force going this way, and you hit it, well, then it's going to go the way you're going. And so this mechanics, I argue, does explain an awful lot. It certainly explains what gravity would be now, because now we have an explanation for what's causing the deficit in the field. Why things are moving in is because the universe is full of a bunch of stuff coming in from all directions. Everything in the universe is being hit by energy, little bits of energy. And the fact is while the little bits are pushing, they're going much slower than they would normally go. So their speed has been spread over the size of the electron or the size of the proton, and that's the reason. Now, the reason why protons are in the inside of atoms and electrons are on the outside is that protons are in fact bigger or heavier, and so when a bit hits a proton, it gives it a far smaller velocity than when it hits an electron. So clearly protons can't do as much moving. It takes a lot more energy to move one. All right, now I could say that's enough to as a preliminary. So just understand the difference is that you don't get to keep the energy of the force. Okay, can't do two things at once. It can't leave and affect other things in the universe and also move the object. So it can't just hit something, cause it to move, and then still be moving. So the force is constantly changing through the universe. That is, it's little stuff moving the speed of light. But it can only do one thing at a time. You know, it can't move matter and still be a force free. Okay, so that's what the old model, you could say, of billiard ball style stuff, or probably some better analogy. You know, where you could give motion to something and then you still go off somewhere else. That's not what this stuff can do. So it can only do one thing at a time. So while it's moving matter, it's not doing anything else in the universe. It's not energy in the universe anymore. It's pushing a piece of matter. And it's not until it goes back to being free, you know, that it's back to being in the universe and going and doing other things. So it can only do one thing at a time. And, you know, like I said, that's the deficit that creates gravity, because there's a bunch of force going much slower inside of material objects, so they have less energy in a sense. You know, the little bits aren't moving the speed of light anymore. They're not doing many things per millisecond anymore, as they are on the outside. That's why everything moves in. So, all right, find the eraser. Yeah, sorry. I have to have more space for better organization and such. Anyway, all right, so let's go to bigger things and what the idea of something's quantity or quality of motion is. Okay, that something's going a speed. Well, it means that each one of its atoms are going that speed, and this means that each one of the atoms has to have stuff pushing it in the direction of the motion. Everything has to be pushed. And so there has to be a certain amount of energy in a direction, pushing in that direction. And when it meets something else that also has this energy stuff in it, you know, these little bits. So you could just think of the big piece of matter, and you could just say, okay, well, if I thought about it and said, let's make the big piece of matter a small piece of matter. Let's make it an electron or a proton. What would be the consequence? Well, the consequence would be it'd have to have a certain amount of force behind it, be going a certain speed. So if it's going, let's say, 10 miles an hour, you know, I should say 1 mile an hour, then it would have one. You know, and if it's 2 miles an hour, then it would have two bits of force more in this direction than the other direction. And then 3 for 3 and 4 and 4. So, you know, you can just increase the number. So you can think of anything that's moving as having a number of these bits extra, okay, proportional to its mass. That is, you would know for each bit of mass there would have to be these things, these, you know, these pushers. And so the volume would be just multiplying the mass times the velocity you're going. That would decide how big a tail, you know, if you thought of them as little, you know, little spermazoa or something, and they were, you know, every moving bit had a little tail pushing it. Well, the size of the tail is going to be a reflection of a volume that's going to be based on, you know, the mass, the number of bits that have to be pushed, times the velocity that you actually go. You know, the velocity will tell you how many, the mass will tell you how your dimension in this direction, your velocity in this direction, and that tells you the volume of little bits that you've got occupied doing something, pushing, okay? So it's telling you what's pushing it. The amount of extra stuff going this way versus going this way. And this is the extra that this matter has occupied. It has more tails pushing this way, or however you want to metaphor it. So it's like, you could think of it as just a ghost, okay? This is the ghost living inside the matter. And it's just how big is the ghost, you know? So if it's got a small velocity and mass, you know, then, you know, it's got less of a volume, less of a ghost. And what basically happens is when the two objects hit each other, okay, is that you could think of the force as something unstoppable, theoretically. There's no way to stop it. You have to convert it. That is, you have to interact with it and be caused to move and all this kind of stuff. So when when the two things hit, you can think of it in a sense as if the two things are actually merging, and the force is going right into the other object, and this force is going right into this object. And it, by the principle, by a rule you could already establish, or a tendency, is that the force doesn't fly out of the matter, or it wouldn't even be able to get caught in the first place. So it can't just fly out of the matter. It can't just go through and leave and not be in either one. Once it's in pushing, it can only get out of the matter by interacting, with a force or with another material object that causes the reflection that causes it to leave and go somewhere else in the universe. And so that event, whether it's a force hitting a piece or another piece hitting a piece. So I'm just saying, whether it's a piece of matter or whether it's just the force itself, it doesn't really matter. So anyway, so you can sort of understand that what this thing is doing is going to go into this, and what this thing was doing is going to go into this. And that's going to be the exchange of the volumes, and, in theory. But the catch is that it's this velocity argument. So when these merge, so when you have these different volumes merging, something that has a big mass, small mass velocity ratios, that the velocity is basically how many interactions you have. It will decide how many of these little bits reflect off, and so how many you lose at a time. So the idea would be is that the thing going slow, so we'll say this is going 10 miles an hour and this is going 20, can't reflect something going faster than it's going. That is, it can't cause this to go, like say if something hits this, this thing going 10 miles an hour hits something. It can't make it go 20 miles an hour. It can only push it as fast as it's pushing. That is, it can only push it based on how much length it has in this, velocity length. It's only by its velocity dimension. It can only give it that much. It can only give it 3 extra in this direction. It can't give it 5 extra, in this direction. It can't cause this thing to go faster. So, now you can really understand why, the fact is that energy is spread in a very different way between objects of different mass. And so that's really the subject I wanted to get to, the one that it's all just momentum. There's no such thing as any kinetic energy. There's just momentum. There's just, what your volume is. And so if I'm making these exchanges, you could understand, so I'll just make a big object and a small object. And so the small object bangs into the big object, let's say. And so this transfer is going to happen, whatever the state of this thing is, and everything has a state, whatever its volume is, in different directions. It's going to now transfer with this, and this is going to transfer with that. But the transfer can only happen in the sense that the velocities are going to, this one this one doesn't have enough volume, although it has lots of stuff going in this direction, so it has a high velocity dimension. This one has such a big fat mass dimension that this has to spread over each over the huge mass dimension. It can't make just a piece of this go 50 miles an hour. It has to make the whole thing go the same speed. So the 50 miles an hour that this might be going, that's over a small volume. I have to spread that over this huge volume. So I can only take I can make the same size of energy, but I can only make it spread over the larger mass. So I'm going to change the shape, the dimensional shape of the energy. So I can transfer it, but I have to change the shape of it. Now the other catch is that these interactions have to happen within a certain amount of time. You have to put the energy in, spread it over all the bits, and make all the bits move, or it's not going to happen. the energy will just go into one piece of this thing and make one part of it go very fast, right? And the consequence of that is that because the rest of it didn't go, that means you get a little dimple here, and the connected pressure between all the atoms will say to this atom, you can't do that, okay? You're not leaving, okay? You have to stay part of the whole. You're adhered to us. And so what it does is just reflect the energy back, and then the object just bounces off. So it really depends on the whole elastic and inelastic in the sense of whether these are, how this object can spread its energy. If it has to spread it through one tiny piece of surface, that if they're hard things and all the energy has to go through a tiny surface, you can sort of understand that that's where you end up with this scenario where I took the 50 miles an hour and I tried to push just one piece of the matter 50 miles an hour, and it just ain't going to happen. The rest of the matter is not going to comply. All the attachments are going to get, they're going to, like a spring, they're going to collect that energy and neutralize it into all these other atoms moving. And as that happens, it's just going to make it all have to go right back again and reflect, and the object's going to bounce off. But if it's a gooey thing, well, then it can spread it over more surface by deforming, flattening, and now it can move a lot more matter. All right, and so then more of the energy can cause all of the atoms to move in a direction that has some direction, so you'll get part of the energy will go this way and part of the energy will go that way. So, but these rules about the basic idea to understand is that a slow thing, okay, can't make something go faster than it's going. So a light thing can't be pushed as fast as it can go. Okay, you can't give each one of its atoms, you can't convert the volume, okay, the big mass volume into a little sharp thing like that. You can just give it a portion of it, this size. That's the only size you can give the small thing, is this much momentum. You can't give it this much momentum. So even though you have in one dimension large momentum, you can't give it to the object because you can only give it the velocity slice that you have. You can only give it the size that you have. So small things can't push big things because there's so many pieces of mass they have to push. But it's easier than big things pushing small things, because big things can't make small things go away fast. It can only give it its slow portion of velocity. It can only push it as fast as it can go. So that's kind of an obvious thing. We all experience that. I can't push a car and make it go faster than I can push, faster than I can move. That's not possible. All right, that's one way of saying it. Maybe I'll just take a pause and then I'll say the same thing and maybe say it better, but we'll see. I'll decide what I'm going to do. Well, a decision will be made. I won't do it. My brain will, configure some sort of added argument to make. All right, I should be back. Appears to be working. Okay, anyway. So a point I wanted to make was, so when big objects are interacting with each other, as I try to sort of point out, is that this velocity thing, the reason why this whole kinetic thing comes up is because what happens with velocity is velocity in an interaction. The higher your velocity, the more likely your energy is going to stay in the direction and not be dissipated in other directions. So when two things are interacting with each other as vectors, okay, the length of the momentum line will be based on a velocity, okay? So you'll see that, something like that. So if they're interacting at some angle, the composite angle, okay, will be more driven by, what you end up as a product by velocity. So velocity has more to do with what direction, okay, the byproduct will be. So if you have a strong this way, then you're not going to have much deflection, right? Where if this was a shorter line, then you'd have a lot of deflection. So the stronger the velocity line, the more control that has over the direction of the interaction, which way it's likely to go. So when two things, little atoms, are hitting each other, combining, and these are going very fast, it means that when they hit the object, they're going to tend to stay in this direction, where the motion in the slower object is going to tend, to be the faster vector, will dominate. And so the direction change is going to be more likely to be in all kinds of directions. I should draw those over here. So that's why velocity appears to make something more powerful, is it makes it more capable of boring holes. So high velocity means you're likely to plow through something because you keep pushing your force in the same direction, which means you're essentially, pieces of you that are moving forward are moving stuff in front of them forward in your direction, which means they're pushing stuff forward and they're pushing stuff forward. So your energy keeps going forward. You keep transferring it. So if you can think of it as you hitting something, now you've exchanged your momentum with it, and then it exchanges momentum with something, and it exchanges momentum with something, and so it just keeps going in the same direction, where if you're going slower, those vectors are going to mean that this starts happening. Stuff starts moving in other directions, and so the energy is getting dissipated in other directions, and eventually will become heat going in all kinds of directions rather than what you want. What you're going to be impressed by, which is how far did it go into the substance. So clearly with clay, the atoms that are moving slow compared to the other ones, they bore through. But if I took cornstarch, which automatically is, what the very idea of it is to transfer the energy in these other directions. It gets rigid, and everything communicates. It turns into a solid essentially with motion, and so the energy gets converted in its direction, and so it doesn't go forward because it's going in all these directions instead. All right, so then you can get to the things like swirling water, which was the jewel was named after a brewer who did experiments just trying to figure out how temperature worked. And so the idea would be is that you would stir water. So you could say this is looking down at a vat of water, and I put a propeller in it, and I move the propeller, and I turn the water. Well, what am I doing when I'm just moving water in a direction? Well, I'm moving it in one direction so I can see the motion, right? Where if I just jiggle it, I don't get to see it as much because, it's going in all kinds of directions. So you can sort of understand that it's really the same thing as heat. Moving the water in a consistent direction, all the water's going the same way, is really the same thing as having water going this way and water going that way and water going it still adds up to the same thing. So of course it's measured as heat. If I put a thermometer in here, all the thermometer cares about is how many bits of energy are hitting it. It doesn't care that they're all going in one direction. It just cares how many atoms hit me. And that's what the temperature thing's really measuring, is just how many atoms are hitting me. So if I'm swirling the water or I'm jiggling the water, it doesn't really matter. It's going to be read as heat. Now, it's not formally heat in the sense that you've moved the water, it's doing a consistent motion. So it's more like putting energy into a flywheel. But the fact is the way we are going to read it, it's going to be read as heat, just as it would be read as heat if you did that with a flywheel. If you spun a flywheel and then stuck a thermometer on the edge of it and created friction with the flywheel, you would read it as heat. You wouldn't read it as something else, even though it's mechanical energy that you could take it off with a generator and turn into electricity. You could use other methods to convert the energy, because the energy is still in a pretty coherent form in the sense that it's still in a very circular motion, but it can be read as heat. So there's a difference between formal heat. It's like light. There's the laser beam and then there's the light bulb. They're kind of very different, and they'll create different effects depending, but they're really the same thing. It's just photons. So, so I mean, that's the thing to understand, though, is that the energy. I've sort of made this point before. If I was using a bowling ball and I was hitting pins, well, if I line up the pins just right, you know, in a straight line, and I actually do hit them perfectly straight into each other, the same energy, okay, will last a long time, and I can knock down maybe 1,000 pins that way, because I keep all the energy in the, it's all in a controlled transfers. And so the only energy I'm losing is the little bit of sound I might make and a little bit of air resistance. But because I've kept them all going in the same direction, I haven't got the energy going into the walls, and I don't have it going into the ceiling, I don't have it going into the floor, I don't have it going into a lot of other things, because I'm forcing things to just bang right into each other and keeping the energy confined without letting it spread. And so what we get fooled by is systems where, you know, they transfer the energy very efficiently, are systems where the energy is getting lost very quickly to other surfaces, other objects that are moving, where we can't see it because, you know, like the deformation of clay, if I hit a piece of clay and I flatten it, you know, I throw it against a wall, you know, all of this energy, okay, of moving atoms in all of these spreading dimensions, you know, those will, you know, optically, you don't appreciate how much energy it took to move all of that matter, and that all of that matter moving means that it's also moving atmospheric matter and moving a lot of other things that you're not going to appreciate how the volume of energy that is now in the environment, because this communicated to the environment so much better. So then you could argue that even heat can be contained in a bottle, you know, a thermos, so you can create a vacuum, you know, it's a very strange thermos bottle, but anyway, all right, by having two layers and just having no air in this layer, so the only kind of radiation that can escape is photonic radiation. You can't, nothing else can get through here. It can't just vibrate this atom and then vibrate atoms in the vacuum and then vibrate the surface and then get the energy out. So it stays inside the bottle because it doesn't have a way to dissipate the movement, to transfer it. They can't hit this thing, that this atoms in here can't hit the atoms out here because of this layer you put in between of nothing. And so all they can do is radiate photons by breaking, you know, rubbing into each other, knocking electrons off, creating, you know, photons. So, you know, that's the only thing they can push with. So very little energy leaves because of that reason. But again, it's always a transfer, and the key thing to understand is that friction and deformation are real transfers. They're not just some thing that happens. They're real transfers. So if you have something that's moving and then you have some kind of surface, you're actually giving the momentum to the surface. You're actually causing the pieces to move, and then they'll get, you know, they're banging into each other and the heat will dissipate. This is real energy going in the direction you're not going in, and that's why you're losing energy, is because you're really transferring it through friction. You're really transferring it through air resistance. The little air molecules are actually moving and they're going off, and, you know, they're turning your laser beam into, you know, they're scattering your energy. It's probably a way to think of it. Friction is scattering your energy. And so your laser beam's getting less and less effective because the photons are now going in all kinds of directions. And it's the same kind of argument. So you can't lose it and then also hit something over here and transfer all of your energy. It's not possible for this thing to have your energy if you moved a bunch of other stuff over here. If you moved a bunch of atoms in the environment already, you can't. You have to do it out of your momentum. So even when you're going to transfer your momentum to something else, you have to accept the fact that you're not going to be able to do it in some ideal way. You're always going to lose something to the environment. And what's the other point to make? Can't think of it. I had it and I lost it. Okay, well, that liability of live TV. All right, so I'll do some more thinking. Think if it comes, rises, and if not, we might just call it a short and whatever. It's just short video. All right, I don't think I need to draw anything else to just sum up. So look, the key point is that energy is a volume of motion. Okay, so you can either have it in the form of a few things moving very fast, or a lot of things moving very slow, and it's just a volume. And that's, it's hard to say that that's how Newton saw it, but I mean, pretty much that's how Newton saw it. Okay, even though he didn't understand atoms and all that stuff, he had some impression. And that mechanics worked. It didn't fail in any way. It wasn't deficit in any noticeable way. And there was absolutely no reason for anyone to believe there was some other kind of energy in the universe or some other kind of mechanism that caused things to move in the universe, because Newton's mechanics worked by understanding it as just a volume. And this kinetic energy formula breaks that notion of a rational volume by squaring a dimension, by causing one dimension to be hugely inflated for absolutely no good reason. Creating giant volume numbers when they don't have the giant volume numbers. And it's just a fact. There's only a certain number of watts of energy. So the laser beam looks like a lot of energy, but it's not more energy than the light bulb, of the same wattage. There's not more little bits of stuff hitting little bits of stuff. It's the same amount. It's just that you focused it all. So if I took a volume of water, okay, going through a hose, the hose makes it look like it's impressive, like, wow, this water can do a lot of stuff. But if I spread that same water over a mile of distance, right, or even the length of the hose, if I made the nozzle as long as the hose is, you could understand that water would look feeble. There'd be so little of it falling over the edge of the brick, just dripping down. It wouldn't look like much. It's the same pressure, it's the same amount of little bits of energy, but it doesn't look impressive. And so how things look isn't basically, it's like the first rule of science should be, don't be fooled. Seems like isn't is like. And I've made this point, and the fact that people can't even just universally agree that that's really what a scientist is supposed to be is careful and not be fooled. And I'm just saying it's kind of obvious that, it's been fooled. It's been, it's gotten caught up in, semantics, visual semantics, and lost its ability to see reality through a misimpression. So it's just volume. Energy is a volume of movement, and the movement can be with a small number of things going fast or a large number of things going slow, but it equals the same thing. It's just about how much push you can put into the universe. You can push 10 times like that, or you can push once like that, and those two things will equal the same thing. They'll cause the same general effect in the universe in terms of what things have changed. The same amount of change, the same volume of change. So how else to say it? We're waiting on, the Stephen Bro is supposed to have made, Bruff is supposed to have some evidence to contribute. Big promises a month now, probably 4 weeks or something. Waiting on it. He apparently did the experiment, has a video proof, and yet he's not going to show it to anybody. Until he puts porn images and rock music to it. But anyway, just pointless. So we're not going to get anything. And the AB science, he's communicating, but he's just communicating insults. He doesn't have any evidence or reasoning or logic or any counter arguments. The point is I can keep countering his arguments and he'll keep ignoring the counter argument. I can keep asking him questions. Do you really think? Okay, do you really? This is the same as asking, does a 5-watt light bulb or a 5-watt laser, does one of them have more energy? It's the same as me saying to you, does a 5-ton train going 10 miles an hour have more energy than a 10-ton train going 5 miles an hour? They don't have more energy. They have the same amount of energy, the ability to push stuff. It's just that one's doing it very aggressively, and the tendency is that its energies will stay in that direction because of that aggression. Okay, and one will dissipate its energy easier in different directions. But that's it. There's no difference. There's just a difference in what direction the energy will be transferred in. Velocity means it's more likely to keep going forward. That's all it means. It doesn't mean that there's more atoms being moved. All right. Yeah, that's all. I'm you know, I I have no reason to apologize, actually. I'm sorry that physics has been done badly. I'm sorry that intelligent people, haven't been careful, and they've been bandwagon jumpers and bigots and idiots. Unfortunately, human beings are frail, and even smart ones can get caught up with, can attach themselves to silly notions. Not my fault. I'm sorry the economic system is ludicrous, because the economic people are just obviously insane and don't understand it's unsustainable and it can't work. That to break all of the mechanisms created to prevent disaster. And that's what they've done. Okay, they've taken all the parachutes out of the airplane. They sold them. Okay, they've done everything they can to ensure that when disaster happens, it'll be the fieriest, worst crash possible. They put the gas tank right underneath your seat. Now, it works until it explodes, right? Then it's not going to work. Okay, and This is just a fact of the world we live in, okay, is that smart people haven't done a very good job. And it's sad, but it's just the truth, because they haven't been very careful, and I'd say they haven't been very well motivated, because they haven't been looking for the truth. They've been looking for, gingerbread to eat. They've been looking for a fairy tale. Star Wars, Star Trek, whatever, free energy, whatever, and that has bled into their judgment, and it's not. There's no case that better illustrates this frailty than the kinetic energy formula. It was invented for all the wrong reasons. It was defended and propagandized for more wrong reasons. Okay, first a religious kook, then free willers, people who wanted physics to be more interesting, and then it was just rationalized by mathematicians, and that's it. They just created some circular math to justify what is physically ludicrous. Laser beams don't have more energy. Same number of photons. It's just when you point them all in one direction, they look more aggressive. It's just a fact. They could do it with anything. I could do it with freaking rabbits. If I had 1,000 rabbits and I set them upon you, okay, all marching in the same direction right for you, okay, it's going to look a lot worse than if I send them in all directions. It's not going to look like an infestation. When they're going in all directions, you're just going to say, oh, there's one rabbit in my yard. No big deal. But if all the rabbits go to your yard, well, then it's going to look like a big deal. It's really that simple. And it's not my fault something that simple has been overlooked by an awful lot of intelligent people. That's just tragic. It's just the sad fact of history. So, till the next time and such, I can just reason with you. Again, if you're unreasonable, belligerently propagandist, you can't jump off of silly notion train. You're on the silly notion train and you just will not get off of it because you paid for a ticket and it's going to some magic land and I will not accept. I can't do anything about that except lament your doom. okay, that you're dooming the human race because you're basically saying, you can't reason with me. Okay? My team, the Yankees, are the best baseball team ever. No, they're not. You're just delusional. Let it go, and buy your ticket to the truth. Say that's the only ticket you want. Say it, and then do it. Do what it requires. Do what honoring the truth requires, which is you accepting when you're being unreasonable. And you're being unreasonable. I've proven it.